Hey everyone! Today we're testing if Coca Cola cans can actually produce power. Using a multimeter, we'll debunk the myths and find if there's real energy inside. Let's dive in! First, empty the cans. We'll save the soda as our electrolyte, but the aluminum container is the real key. Let's prep them. After sanding down the rim, we're using pliers to pop the lid right off. We need a wide open top to get inside and prep the surface for our reaction. This is starting to look like a real lab experiment now. Inside each can is a plastic liner blocking the metal. We sand it off to expose raw aluminum, then pour the Coke back in as our electrolyte. We need copper for our positive terminal. Aluminum is negative, copper is positive. Together with the liquid, they'll generate electricity. Connect the leads to the copper and the can. The circuit is closed and the multimeter shows 0.54 volts. Connecting the cable to the copper and submerging the other lead, we're closing the circuit. Let's see if this setup generates the power we need. There it is, 0.55 volts, third of a battery. We generated real electricity from a Coke can and scrap copper. It works! There it is, 0.55 volts, third of a battery. We generated real electricity from a Coke can and scrap copper. It works! The truth, 11 cans gave us 4.2 volts, but it's crashing down to 2.4. There's voltage, but not enough current to charge a phone. Myth busted! The truth, 11 cans gave us 4.2 volts, but it's crashing down to 2.4. There's voltage, but not enough current to charge a phone. Myth busted! Using aluminum foil and a saturated paper towel, we're creating a powerful chemical bridge. This sodium hydroxide setup is the secret to hitting a steady 1.5 volts. Adding steel wool and pressing down completes the reaction between the aluminum and steel. Let's see how much power this sandwich cell delivers. 1.15 volts. That's nearly the power of an AA battery. It's a massive jump from the soda cans. We finally have real, usable power. 1.15 volts isn't enough, so I've built 10 cells in series. We've pushed the output to nearly 10 volts, creating our own handmade power grid. Let's see if this can finally charge the phone. 10 cells in series give us 10 volts. Let's see if this handmade grid can finally charge the phone.
Steady 9.6 volts, 7 times a AA battery. Stable, powerful, and ready. Let's put it to the test.
More solution! Brighter LED! We're at peak power! Time to charge a real device!
10 volts, but no charge. Phones need stable current, not just voltage. Our DIY grid falls short. The iPhone said no, but the power bank? Lights are blinking. Our 9-volt grid is pushing enough current to actually charge it. Proof our DIY battery works. Testing the ancient Baghdad Battery myth. I'm filling this copper jar with salt water and an iron rod. Legend says it generates electricity. Let's find out. Connecting the iron core to the copper cylinder gives us just 0.1 volts. Even with 10 of these, you'd barely power anything. Looks like this ancient mystery is more myth than a real power source. The Baghdad Battery reality. Copper, iron, and salt water produce just 0.1 volts. That's virtually nothing. Can't light an LED or electroplate gold. The legends seem exaggerated, but I'm not giving up yet. Swapping salt water for sodium hydroxide. If this doesn't spark a current, nothing will. Let's see if a modern boost can finally bring this ancient jar to life. Sodium hydroxide boosted the voltage, but it's still too weak. Ancient materials were simply too inefficient. Coke cans produced electricity, but the voltage dropped fast. From 4 volts to nearly nothing. It's a cool trick, but it won't charge your phone. Winner: aluminum and steel wool. Nearly 10 volts lit an LED and charged a power bank. The ultimate DIY battery. The Baghdad Battery? Fascinating history, but a myth as a power source. Just 0.1 volts can't plate gold or power anything. Likely just a storage jar. Testing myths against reality. Some worked, some didn't. Thanks for watching. Subscribe for more experiments. See you next time. Science tests myths against reality. Some passed, some failed. Thanks for joining me in the lab. If you enjoyed this, hit subscribe, and I'll see you in the next experiment.